Hey everyone, thank you for tuning in. Today we will be talking about basic SQL injections. We will first go through how SQL injections occur and what kind of vulnerable code causes them. And then we will go over some examples of how to exploit them using very basic techniques. And finally, we will end up with how we can patch this code. We will go through this entire process from a code review / secure coding perspective, so that we can understand how it occurs from a developer point of view, and how we as attackers can leverage all of the vulnerabilities and mistakes to manipulate the SQL queries. So we will be going over it through the SQL injection fundamentals module, which is part of the bug bounty hunter path and the junior penetration tester path. And we will start with the union injections section, which covers the first type of injections that we want to cover today. If we go to the intro to SQL injection sections, we will see that there are various types of SQL injections. And very basically put, we have in-band SQL injections, blind SQL injections, and out-of-band SQL injections. In this case, we will be focusing on in-band and union-based SQL injections, which is the very basic, the most basic type of SQL injections. Other than that, we can also leverage something called an error-based SQL injection. So even if we cannot somehow get the output of the query, we can utilize errors if errors are enabled. In addition to that, there are somewhat more advanced types of SQL injections, like the blind SQL injection, in which we do not have any output of the SQL query that is being processed. For example, like a login request. It is obviously using the database and executing some query to validate our login credentials, but it is not giving us the output of this query. So we are blind to the output, but if it is vulnerable, we can still exploit it using techniques like Boolean-based SQL injections to see if any changes occur on the page itself, like an error message, login failed or something, or even a time-based technique, which completely depends on time delays in the SQL queries being executed with no output whatsoever. There's also something called out-of-band SQL injections, in which we utilize the database to send queries to our own server so that we can receive the output or whatever kind of notification on our own server. But like we said, today we will be focusing on the most basic type of SQL injections, which is the union-based SQL injection. So we will go to the union injections section, and we will see this exercise. We already have this exercise running right here locally for the purposes of this video, so we can demonstrate it along with the code, and then later on we can patch it and so on. So this is a very basic search query. Obviously, in real web applications, such queries would be part of a larger web application. You would find it at some page in which you can search for various stuff. And in this case, we have isolated just this search functionality for the demonstration purposes to teach SQL injections. So if we search for anything like a single letter, and we get the results, obviously. But as attackers, we always go to the mindset of testing for SQL injections. So we will try to add some SQL injectable payloads, like adding a single quote. And in this case, we see that it gives us an error and the query fails, which indicates that we somehow manipulated the SQL query and may have caused an error and an issue that worth investigating. Obviously, in some more complicated cases, we may not be able to just inject a single quote or something and cause an error, but we may have to fuzz using a word list of SQL payloads and then just run through various possible payloads that may cause an error. Or we can use an automated application like SQL map, which we also have a module that covers, and it will just go through various payloads and try to exploit this vulnerability. Obviously, it is very important to understand how these vulnerabilities occur so that we can manually exploit them, and for very advanced cases, this would be perhaps the only way of exploiting such vulnerabilities, as common payloads and applications like SQL map would not work. So let's investigate this further and see what is happening. So like we saw earlier, when we inputted a and then a single quote, it caused this error. Obviously, in this case, we are getting the PHP / MySQL errors, which can be really helpful for error-based SQL injection exploitation techniques, but this can also be done without having errors. We are just showing errors in this case to further demonstrate and further understand how SQL injections occur. So let's go back to our code and see what is actually happening. So this is the query that gets executed when we do this search functionality. We see that it gets the port code from a GET request. This is PHP code, and we see here port code and whatever input parameter we have. And then it takes this query, which says select stars from port where code like %, which is for SQL queries, which is like, and then it directly inputs our input from port code, and then it wraps it between percentage marks, which basically it says something like whatever input we put. Obviously, we can directly see that this is a very dangerous practice. First of all, it is taking our input and directly inputting it within the SQL query without any sort of filtering, sanitization, or validation. In this case, we have the ability to change the SQL query because this query, including whatever input we have, will get turned into a new query and will get executed with this MySQL query function in PHP. So let's take an example here. We have this exact query here, right? And let's just remove this for the to better understand it and just input our code. So when we did A, the query was select stars from ports where code like A, and this is a valid query, and it gets executed and returns the output, a few rows, and they get displayed here. MySQL fetch query. So what would happen if we added a single quote like we did earlier? What would happen here is that this SQL query no longer works because it has unbalanced quotes. We see that we have 3 quotes here, and it will try to execute this query until it reaches here, and then it will find this dangling single quote, and it will fail. The query no longer works, and we have thus caused the error that we saw earlier. And this is because we have direct input within the query, and this query gets turned into a new query, which is what we have here, and the PHP application tries to execute it, and it fails. So we have complete control over the query. Obviously, when I say complete control, I mean that we can have whatever input we want and within the query itself. We cannot, for example, delete this and just completely replace it with a new query. That's not possible. So how can we exploit this? We know that we are stuck with this part. We cannot change anything before our input. We can only come from here onwards. So in this module, the SQL Injection Fundamentals module, we teach various techniques of how we can execute such vulnerabilities. One thing we can do is the aforementioned union-based attacks. We can go back to the union section and see how this can be exploited. Now, this technique depends on what is called a union clause, which is a SQL query that we explained in the previous section. But basically, it tries to execute 2 different SQL queries and tries to merge them into a single query, which is a perfect match for this case, because we already have a single query that is already being executed here, and we want to add another query. So the union query is a perfect match for this one because we can add another query and have it execute with this query, and we can get the output right here within the same search output. However, for this to work, we need to have both queries have the same number of outputted columns. For example, in this case, if we search for A, we can see that it has 3 different columns. However, this may not be the case. It may actually be getting 5 or 6 different columns and only displaying 3. So what we have to do first is to find out how many columns this query has. And then we can create another query with the same number of columns and have it execute both queries successfully. So first, let's see how we can find the number of columns. The section also shows different techniques we can utilize to do so. One method to do so is to utilize this method, order by, and then specify the number of columns until we get a success. One thing we can notice is that we are using a comment, which is -- space, which is the comment in MySQL. What this does is that whatever we have after it will be blank and commented out. So this is as good as deleted. So we have to only worry about what's before it, and we can ignore whatever is after it. We can also just cook up a good SQL query which will work with whatever is after it, like adding a couple of percentages here and so on. But using comments is always easier because we don't know what is after it unless we have the source code, obviously. So if we try this payload, we see that it does work. We have to keep trying until it does no longer work because it has one column, and so column number 1 will work. Obviously, it will sort by this column. 2, let's try 4, still working, so it has more than 3. 5, okay, it no longer works. This means that it has no column number 5. So we can deduce that it has 4 columns, and the new query that we will use with the union injection, which we will get into in a bit, has to have 4 different columns. There's another technique we can use, which is the union select. We can just do A and union select 1, 2, 3. This will not work because it is trying to, the current query we have, we just found out that we have 4, but it is trying to union between a 4-column query and a 3-column query, which would not work. So we have to keep trying until it works. So the previous one, we have to keep trying until it does not work, until it stops working, because it cannot sort by column number 5, for example. In this case, we have to keep trying to unionizing with another query until we find the correct number of columns. So if we try 4, it should work as we expected. So what we have found out so far is that the original query that is being executed has 4 different columns. So now we have to create another query that has 4 different columns and use the union clause to execute both queries. So as we mentioned earlier, we are trying to exploit this application, and we are trying to change the original query that is being executed, and we are trying to add our own query, and hopefully we can get some new information displayed here. So with that in mind, let's see how we can create another SQL query and execute both of them using the union clause. To do so, we can use the same payload that we just used to find out the number of columns. We can just do A and then inject a single quote and then use the union SQL operation and then add our new query. So it's very basic. We already have one query that is being executed, and this is our new query that we are injecting, and we should be able to get its output. Before we go into finding out the different tables and so on, we can start by doing something like @add version, which is a SQL MySQL command that should work without specifying a table. So we can do union select @add version 1, 2, 3, 4. We have 4 different columns, so it should work, and we don't even need a table name. We see that the last row changed to 2, 3, and 4, which is the whatever input that we earlier used, 1, 2, 3, 4, and we see that 2, 3, and 4 were displayed here. So we can use any of these parameters to inject a new query that we want. Earlier we did @add version and parameter number 1, but this is obviously not being displayed, so it's not a very good choice. So let's go with number 2 and see what happens. And we see that we did indeed get the version of the MySQL database that is being run, and we have successfully executed an SQL query. Now, the module covers various techniques and SQL queries we can use to find out all different tables available in the database, and the database name, and then also all different rows available in a single table, so that we can create our own customized SQL queries, so we can fetch the exact row we want from the exact table that we are looking for. You can refer to the module for all of these details, but for this case we will just use our cheat sheet and try to find the SQL query that we are looking for. List all tables in a specific database. This is exactly what we want. We can just copy it and try to use it here. So we can just use search and see what happens, and it says credentials, pages, posts, and framework. So we have 4 different tables in the database. So perhaps we want something from the credentials table. So let's see all different rows available in this table. We can once again use this query, which says in the cheat sheet, list all columns in a specific table. Okay, and we can just search, and then it says username and password. Okay, so now we know that we have 2 different columns, username and password, in a table called credentials and the database called dev. So we can do union, and then add our new query, select to username password from dev, which is the table we have to specify, because which is the database. It could be in a different database, and then credentials. Then we can just comment it out and do search. And we can see that we are able to view the different credentials that were found in this database. So we have been able to successfully subvert the original search function SQL query and add a new SQL query that we executed to reveal some sensitive data from the database, which in this case is the credentials, username, and password hashes. Finally, we want to see how we can patch this code and turn it into a code that is safe against such basic exploitations. We can go to the mitigating SQL injection section, and we can see various techniques we can use. The very first technique we can use is input sanitization. We should always make sure that we remove any unsafe characters from the user input. In this case, it shows us how we can use this PHP function to remove these characters. Of course, in other frameworks, there are different functions that we can use, but in this case, let's try to use this function and remove any potentially dangerous characters that may be in the user input. So instead of directly inputting the user input within the SQL query, let's try to sanitize it first. So we can use the same thing from the section that we copied, and then replace the parameter with our own. Finally, we can use the input within the SQL query. Save it, and let's try again. Inject doesn't work, and the normal functionality works. So this is one way to ensure that we cannot input any unsafe characters within the SQL query. And this is a built-in PHP function just for MySQL sanitization. Another thing we can do is use input validation. If we were looking for an email, for example, we can validate that it is actually in the email format. For example, we can use regex, and we can use various PHP functions or Node.js and JavaScript functions to validate that this is actually an email. In this case, we are using a search function, so we don't have a single pattern, so we cannot actually validate what is being written. The final thing I want to discuss is parameterized queries, which is something that we should always do whenever we do SQL queries, either it is in PHP, JavaScript, or any other framework. What we have been seeing so far is that we take our input and directly input it into the SQL query, which is a very unsafe practice because it leads to injections. This is not only unsafe for SQL queries, but also for command injections and all other types of injections. They always occur because we try to input a user input directly within the command that we are trying to execute. So we always suggest to use parameterized queries to avoid injections. So as the example shows, what we have to do is to first use question marks where we want to place our input. After that, instead of directly executing the MySQL query, we can use the example here and prepare a statement that is safely parameterized against potential injections. So first of all, we prepare the SQL query, just like we have been doing here with the connection and the query itself. In this case, we have Q. Second of all, we have to bind the parameters to the statement. So the first parameter is the statement we have just prepared, and the second one is the type of parameter we have. In this case, we have just a single one, which is a string, so we provide an S. Finally, we have to put our input here, and we will use the sanitized input that we just prepared earlier. So this is our new query. Finally, we will execute this query in a safe manner, and at the end, we'll get the result here using this statement. So we no longer need this. So let's go over this again. So the first thing we did is we created a new variable that is sanitized based on our user input. So we no longer need to use this user input, and we can just use this new sanitized variable. Second of all, we created a query with a question mark, and this question mark will basically be replaced by our input. Obviously, we have to remove the quotes here, otherwise the question mark will just be considered as a question mark character. So whenever we use the parameterized queries, the question mark has to be within the query directly. So let's just add the percentage marks characters right here. So we just have a single question mark here, and later on we will bind both of them. So our input will go in place of this question mark, and this way we'll have a sanitized and parameterized query. We can just save and try to search again, and we see that it does indeed work. We now reach the end of this talk. I hope you found it useful and entertaining. We have been able to identify an SQL injection vulnerability within this vulnerable application. We then saw how the vulnerability actually occurs and how we can actually inject new code to execute new SQL queries. And at the end, we were able to patch this code and make it a safe code. Thanks everyone for tuning in, and see you next time.